Okay, so before we start the example problem, there's a couple things you should know. You should know the equation for torque, which is T equals Fr sine of theta. So the F is the force in newtons, the R is the length of the lever arm, and the sine of theta is just sine of the angle that the force is applied at. Another thing to remember is that the max torque that can be applied with the same force will be at 90 degrees because the sine of 90 is 1. If you go a little bit above that, it'll be less, and if you go a little bit below that, it will also be less. One way to think about that is that if you're going to open a door, it's easier to push it straight on, right at 90 degrees, than it is if you push it sideways with the same amount of force. Okay, so let's go through this problem. Okay, so the first thing you want to do is you want to draw your diagram. So door is a straight line. We have it right here. You have the force of Pablo, 50 newtons. You have the force of Jaquarius here at 90 degrees, 650 newtons. You have the force of Big Bruce up here, 400 newtons at 45 degrees. Doesn't really matter if it's coming from this way or this way. And then you have the force of the magical alien in the wall, 800 newtons, which is right in line with the door. So you use your equations for each one, and then you'll add them up to get the net torque. So we find that the torque of J in the first one comes out to 975 newton meters. Pay attention that it is positive because it is going in the counterclockwise direction. Second one, torque of P comes out to 0 newton meters because it's right at the hinge. Okay, so next the torque of Big Bruce comes out to negative 537.4 newton meters. Remember, it's negative because it's rotating it in the clockwise direction, or trying to. Last one, you have the torque of A, 800 times 2, but the angle is 0, so it'll come out to 0. So the only two numbers you have, 975, negative 537.4, add those up. Your final answer will be 437.6 newton meters, or with three significant figures, 438 newton meters, and that is your net torque.